Welcome to the Living to 100 Club podcast. Here's our host, Dr. Joseph Casciani.
Well, hello to everyone joining us today. You're listening to the Living to 100 Club podcast, and I'm your host, Dr. Joe Casciani. I'm passionate about helping people embrace psychologically healthy aging, staying positive, finding purpose, and making the most of all the years we're given, no matter what challenges come along. This podcast is part of a larger mission I call Living to 100, which brings together three powerful tools. These podcasts for insight and inspiration, our Better, Longer, and Happier card deck series for hands-on programming in senior living settings, and the Living to 100 community, a place to connect, learn, and thrive together. To learn more, visit my website, livingto100.club, and livingto100.solutions to explore the card decks for senior living communities. Thanks for being part of the journey. Now let's dive into today's conversation. How healthy is your brain? And how do you really know? In this episode, I welcome Dr. Mark Tommerdahl, a leading neurophysiologist and co-founder of Cortical Metrics, to explore the science behind the brain gauge. The brain gauge is a groundbreaking tool for objectively measuring brain health. Mark shares how this compact device is being used to track age-related cognitive changes, support autism research, improve concussion recovery, and even guide lifestyle changes for better mental performance. And Dr. Tommerdahl is offering a $50 discount for listeners of this podcast on his brain gauge device. You can learn more about it at corticalmetrics.com. First, a little background. Dr. Mark Tommerdahl is a neurophysiologist and associate professor in the Department of Biomedical Engineering at the University of North Carolina at Chapel Hill. He's the co-founder and president of Cortical Metrics, the company behind the brain gauge. His research centers on cortical interactions and sensory information processing, particularly as they relate to neurological conditions such as autism and concussion. Dr. Tommerdahl, thanks very much for joining us today. Welcome.
Yeah, well, thank you. Thank you for talking to me.
Great. Yeah, happy to have you here. Looking forward to this. So let's just jump right into it. Tell us about the brain gauge. What led you to develop this tool, and what sets it apart from traditional neuropsychological tools?
Well, first of all, a little bit more about my background is I started off I am a neurophysiologist by both training, and I still think of myself that way. And that means I studied sort of the fundamental building blocks of information processing. And so and the way I studied that was, from the early 1980s until mid 2000s, I was studying how different parts of the brain interacted. And we did this, in the lab with different animal models,
Mm-hmm.
from non-human primate all the way up to rat. And we're still doing we still do the research with rats, but we're interested in how different parts of the brain interact, especially, in order to assess the overall network. And the brain is a network. And so connection and connectivity between different parts of the brain is everything. And so we developed some measures in the lab that were very sensitive to looking at how healthy the network was. And those measures were extremely repeatable, extremely redundant, one animal to the next, even from, whether it didn't matter what type animal it was, but those were very, very robust unless something happened to the brain, unless there was some kind of insult. And if there's some kind of insult to the brain, then those measures just fly out the window. And so once we sort of established how we got those things in the brain, and we did this by recording with an extracellular recording, sticking needles in the brain
Mm-hmm.
and taking pictures of the brain, very, very high resolution images where we could see where big groups of neurons were interacting. And once we sort of established what to do, we start, well, let's start doing the exact same thing with humans, except we weren't sticking electrodes in the brain. We were just asking people questions about what they felt, which seems kind of silly because it's, but it's not. But basically, we deliver stimuli to the fingers. The brain gauge looks like a computer mouse, but it's actually, it's actually a lab that's inside something the size of a computer mouse. And we use that to deliver vibrations to the fingertips. And those vibrations activate very specific parts in the brain that interact in a very specific way. And by asking very simple questions, we ask which one's bigger, which one lasts longer, which one came first. Very simple. Now, the vibrations change and the vibrations are somewhat complex, but the way that the tests are delivered is on the fingertips is really the same way that you might read an eye chart. Starts out very easy and then gets very hard. And how far along you can get tells us a lot about your brain health. It tells us a lot about how your neurons are interacting and how well they're communicating with each other. And, basically the first time we did a study where we correlated human response with what we found in the lab, we got a 98% correlation. So we know that we're targeting very basic fundamental building blocks. And the way you think about these building blocks is everything else is built on them. Things like language. So we don't depend on language because, like I said, very simple questions. And most neuropsych tests target sort of try to drill down from the top, look at the cognitive or executive function. They try to drill down what the problem is. But we're starting right at the very base foundation.
So what are some of the, in layperson's terms, what are some of the performance indicators? What gets revealed in the brain gauge results?
Sure. So we have a couple different things that we have on the brain gauge in terms of testing. One is we have a very simple 90-second test, and we call it the quick check. And people use this just to sort of get it's a little bit like taking your blood pressure. It's sort of a vital sign. It tells you how well you're doing. Blood pressure tells you gives you a lot of information, but it doesn't give you many specifics. It doesn't say why your blood pressure is high.
What's behind it?
But the quick check is very good at tracking, gives you an overall assessment. And a lot of people use this daily and they find out, I found out when my sleep habits are bad, my scores get worse. When I'm, different lifestyle changes, if I'm drinking too much, if I'm smoking too much, my scores get worse. And there's, and basically it also gives them sort of a baseline for how they're doing compared to where they should be.
Okay.
Because most people, most people as they age don't realize that they're drifting. But once they start doing some lifestyle changes, they start saying, oh, I think I'm doing better. But the brain gauge gives you an objective measure to say, yeah, you are getting better.
Okay. So the quick check tells you what's out of the norm or what's amiss. So it doesn't necessarily tell you what caused that.
That's true.
Aberration or
well,
miss.
quick check is, right. It's not that specific.
Yeah.
We get a couple of metrics out of it.
Uh-huh.
For one of them is how well you can focus. What is your attention?
Okay.
And even now that at 90 seconds, if your attention's poor, if your attention's very poor, you probably shouldn't operate heavy machinery. You probably shouldn't be driving.
Okay.
But it's, when you're, and so it's one of those measures that's critical for things like attention or for ADHD. People on and off their meds score very, very differently on the attention score.
Okay. So when you describe the device itself, you mentioned that it registers your fingers, and you related to me on an earlier call about the somatosensory cortex, that this is what the brain gauge triggers, the brain activity in that area of the brain.
Yeah.
Tell us more. Yeah.
Sure. And Basically, when I first started, I started out as a biology major at a place called Davidson College, and I went and joined a neurophysiology lab at University of North Carolina. And the person who ended up being my mentor, when he interviewed me to join the lab, I was looking for the right place to work, and he said, "Look, all we want to understand is how the brain works, and to understand how the brain works, you basically just need to know how cerebral cortex works. That's the massive part of the brain. That's the thing that we're really most interested in, and especially in our species. And then, but to understand that, because every part of the cerebral cortex is organized the same way, the best way to study it is somatosensory cortex. So somatosensory is this part of sensation that deals with the sense of touch. And that's a very high fidelity system. And everybody's known this forever. They just didn't know how to study it. They didn't know how to deliver stimuli very well. So the first stimuli that we were using, I mean, they're very cumbersome, weighed 100 pounds,
Hmm.
cost about $30,000 of $1980. So it was very expensive, very cumbersome, very difficult to use. But, you could, in a laboratory setting, it worked very well. Uh, but in somatosensory, the way to think about it in terms of the sensory systems, it is the Goldilocks of sensory systems. Auditory is too small, visual's too big, and
Hmm.
it's just perfectly
Hmm.
organized
Hmm.
and really laid out very well.
Hmm.
You vibrate two places, your two fingertips,
Uh-huh.
and they activate two places in the brain that are side by side. It's just it's a really beautiful design, and it's
Hmm.
really so you can take advantage of that by delivering stimuli to them
Hmm.
or vibrations to your fingertips and asking those questions.
This is kind of the hub in terms of this particular application. What's
Hmm.
going on there in that part of the brain, the somatosensory part of the brain, and then you can draw inferences from its performance from there.
Hmm.
Interesting. Yeah. So in terms of like everyday applications or even clinical applications, what's it telling us about aging and cognitive decline, the brain gauge? Yeah.
Well, I work with a lot of different clinicians who are using this, and and the easiest thing to talk about are basically the people that come into their clinic and who are concerned about aging and onset of dementia. And some of them are coming in for different treatments, and some of them are just coming in and they test everyone with the brain gauge. A lot of these clinicians test everyone doing the 90-second test. And if there's something wrong, they'll do the full battery to get a little more idea but of what's going on. But usually they want to see which treatments are effective. And so they might be doing hyperbarics, or they might be doing ozone therapy, or some kind of microcurrent neurofeedback, or direct current stimulation, or pulse electromagnetic field. There's a lot of different treatments people are using to target people who have either had dementia or stroke in this aging population. And they're using the brain gauge to see what's effective. Sometimes they're using all the treatments combined, and they find that that's effective. But also, a lot of the patients are just coming in and saying, "I'm just going to do the brain training." They use the brain gauge to actually train,
Mm.
to actually activate things in the brain. And the brain training with the brain gauge is really seems to be very effective. From what we see is that people are using it and they're improving things like, for example, they improve their reaction time. That's one of the most commonly, that's probably one of the most important things for people to understand is that reaction time is a really important uh,
Mhm.
feature of your, and it's a really important, not just a measure, but um, it's like when you're driving, you should be able to react to how other people
Mhm.
are are driving. If you're walking across the street and you have a really poor reaction time, you won't notice the cars are coming.
Mhm. Sure.
So it's just
Sure.
it's very practical and very easy and very essential functional mechanism. And if you train at it, you can actually get better. And
Mm.
I've seen some people, I know these numbers mean very little to people, but the average healthy reaction time for people is around 200 milliseconds. And I've seen people with reaction times of 4, 5, even 600 milliseconds get their reaction times back down to that norm or even better by brain training or by different treatments, and it's really encouraging and
Mhm.
it parallels their ability.
So would that be one of the signs then that would suggest some kind of brain dysfunction if the reaction time is slower? 600.
Absolutely. If you go through the last 150 years of literature, there's not a single case, not a single data point where reaction time is in the normative range for somebody that has something, that is in that aging dementia group. There's not a
Really?
single
Okay.
person with MCI or mild cognitive
Yeah.
impairment that has a normal reaction time.
Hmm.
So the question that you flip it on your head and you say, well, if I can get my reaction time back to normal and
Yeah.
keep it normal, does that mean I'll offset that dementia? What you're actually doing is building cognitive reserve when you do training and when
Uh-huh.
you do all
Yeah.
different things. There's a lot of things you can do to improve. And I don't want to say it's just brain training, but what a lot of people are doing and a lot of people with the home units are telling me, is like, well, they doing all the things that they do to improve brain health
Mhm.
that they know they should be doing, things like exercise and good sleep habits and trying to become more active. And they use the brain gauge just to track their progress when they
Mhm.
start improving their
Mhm.
lifestyle.
Yeah. So reaction time is pretty well understood um, process. I wonder what other measures do you get that might be suggestive of some cognitive decline besides reaction time?
So, yeah, well, as you know, neuroinflammation plays a huge role
Hmm.
in severe dementia, and this is one of the things that's very that has a huge impact on some of our measures. So when we do a longer battery that takes 15 to 20 minutes, a lot of the measures we take are very impacted by inflammation.
Hmm.
One of called plasticity, or neuroplasticity. How well can you adapt to your environment? And so we have a measure that tells us, how well is your brain adjusting to new inputs?
Hmm.
And that's the whole thing about your brain is it's constantly evaluating what's coming in, and typically it gets bored of repeated stimuli. And once I repeated stimuli, we deliver stimuli on these tests for about half a second.
Uh-huh.
And when you look in the brain, it's very fascinating to watch the network respond to it, and I get all excited about it because it's really cool. And you deliver like a particular stimulus to the brain, and you see it adapt very quickly,
Hmm.
and then the brain gets bored. And it's like, oh, and unless there's a new stimulus. Now, if the brain's not getting bored, it's that means your plasticity is shot. And so the brain is actually adjusting to whatever's coming in, and
Oh,
that's
oh, I
basically
see. I
yes.
see.
And it only takes about half
Yeah.
a second to
Yeah.
drive the brain to this equilibrium point, and especially when you have really nice clean signals coming through
Yeah.
the somatosensory system.
So I understand neuroplasticity is just a way of telling us that the brain likes novelty, right? It wants to be challenged,
Right.
new challenges. And what you're saying is, if the brain isn't reacting to those new stimuli,
Mhm.
then it's not able to process that. It's not able to.
And on the flip side,
Yeah.
so what messes up plasticity? And I'll give you an example. So somebody on, say, PCP, encyclodine or angel dust,
Hmm.
uh, to them, everything's a new, it's a, they get high, everything's a novel stimulus. Nothing changes. And so when we did in the animal models in the lab, we would deliver, regular stimuli and look at how the brain changes and then administer either ketamine, which is a very common anesthetic, or PCP. And all of a sudden the brain does not adapt, that plasticity is not there.
Hmm.
So one of the first things we wanted to study with humans, well, we weren't going to have people take PCP, obviously, or ketamine. We had them take a single dose of cough syrup. So dextromethorphan, which is an NMDA receptor antagonist, that means it turns off this important system that plays a huge role in plasticity. And when we did that, like in other words, we had a whole bunch of people, it was called a double-blind placebo study. So
Mhm.
we had a bunch of people take a pill
Mhm.
that had nothing in it but sugar, or it didn't
Mhm.
taste, and then a
Placebo,
whole bunch of
sure.
people take dextromethorphan. And the people taking dextromethorphan, they did okay on some tests, but the plasticity test, they did horrible on. They lost their plasticity, but
Mm.
for 3 hours. And
Mm.
we tested throughout that time period until their plasticity returned to normal. So it was
Oh,
fascinating.
okay. So when you're testing someone who's not on that kind of cough syrup, and they perform the same way, that's your brain gauge picking up this loss of plasticity.
Exactly.
Yeah.
And I talked to people who have home brain gauge units all the time. And one person contacted me and they said, "Hey, what's going on with my brain gauge scores?" And they're horrible today. And this is
Mm.
somebody that's just trying to keep track of their overall lifestyle. And I said, "What's going on?" And it was a Zoom call, so I could see, their face. I said, "Do you have a cold?" And yeah, she had a cold. And I said, "Well, are you taking cough syrup?"
Mm.
"Actually, I am." "And you're
Mm.
taking dextromethorphan, aren't you?" And she goes,
Mm.
"Yeah." And I said, "I can tell by looking at your scores
Mm.
why."
Yeah.
And so it does have an impact on your scores.
So it suppresses that type of brain activity.
It
Mm.
does.
Yeah.
And some
Interesting.
things you can still
Yeah.
do okay
Yeah.
on. Now, if you
Yeah.
take a whole lot of,
Yeah.
I mentioned just one particular dose, you take a lot of something, yeah, it does have a lot, it will have an impact. I
Mm.
mean, everything has an optimal dosage. And this
Mm.
is something that, for example, vitamins don't help if you don't need them. Supplements don't help if you don't need them, but people are out there taking a lot of supplements
Mm-hmm.
uh, without really any, they say, "Oh, take this." I see this on, I hear these commercials all the time. Take these different supplements or drugs, and this
Sure.
is going to
Sure.
help you. But they never talk about how much. They never talk about an objective measure for seeing if
Yeah.
it is working, if
Yeah.
it is improving anything.
Yeah.
So, before you
Mm-hmm.
spend thousands of dollars on supplements and
Yeah.
drugs, figure out a way to objectively measure it.
And this is one way because they may or may not be helping or changing anything.
That's
Yeah.
correct.
Yeah. Now you've also studied other conditions like autism and concussion. What kind of
So,
findings can you share with us?
okay, so let me go through the list. We really haven't met a neurological disorder or insult that we haven't seen impact from.
Hmm.
And so we started out, one of the early areas we've been in for 20 years is autism, looking at neurodevelopmental disorders. And so in the neurodevelopmental disorder space is things like autism, ADHD, OCD, Tourette's. Those are some of the things that we've looked
Hmm.
at and published in. And obviously in neurodegenerative disorders, which a lot of your, listeners are interested in, things like Parkinson's and even
Mm-hmm.
diabetes. Pre-diabetics look very different than diabetics in terms of their brain health,
Well,
and especially type 2. Before the onset of type 2, that's a whole different story. About an hour lecture.
mm-hmm.
A
Sure. Yeah.
simple version of
Yeah.
that is that there's some cells in the brain that actually produce insulin, and so they play a big role in inhibition, and the patterns of inhibition change. We also, in the trauma space, Office of Naval Research actually picked, they provided a lot of sponsorship for development of the brain gauge because we had a lot of success tracking concussion recovery. And that's something that, we've done a lot of studies in concussion. And the most recent studies that we're doing in that space are in what we call subthreshold or subconcussive events.
Mm-hmm.
So this is where special forces guys go out onto the artillery range and they fire weapons and they try to and they basically those weapons have a blast overpressure, and it's not a concussive pressure, but it is a subconcussive
Mm-hmm.
overpressure, and we test them before and right after that, and we see that their recovery period is about 72 hours, which is much faster than a full-blown concussion. But it tells you what we're trying to do is figure out, okay, what's the amount they wear blast sensors on their body armor and all
Hmm.
their, and they try to figure out, okay, from the blast sensor data that they get, and we're trying to calibrate those blast sensors to see, well, how much overpressure can they be exposed to? And if they're exposed too much with these sub-threshold events turn into basically you get concussion-like symptoms.
Uh, so I'm
So it,
guessing this sub-threshold event is not detected by the individual,
no,
but where the
no,
brain gauge does pick it up.
yes,
Yeah,
it's true.
which is similar to neuropsych testing that can pick up some of the deficits, early deficits, even before the person knows about them or experiences them. So
Yeah.
just maybe say a few words about how neuropsychological testing is different from what the brain gauge can measure.
Yeah. So neuropsychological, a lot of tests, and I don't, there's more than I do. There's a whole lot of neuropsychological
Sure.
testing going on,
Yeah.
but every one thing is that the brain gauge targets these biological building blocks, and things like that are the foundation for other things. Now, when you start talking about different neuropsychological tests and profiles, there's different ones for every neurological category. For instance, in concussion, you have things called SCAT, or Sports Concussion Assessment Tool, and it's pretty much a symptom score checklist, and
Hmm.
it's dependent on self-report.
Self-report. Hmm.
And a lot of the self-report, it's based either, when you work with college kids who are athletes, well, they just want to go play again, so they'll say, no, I don't have headaches. No, I don't have dizziness. No, I'm fine.
Mm.
But if you test them, then they admit,
Mm.
well,
Sure.
yeah, okay, I'm actually not okay.
Yeah.
Then in the other areas like autism, they have the ADOS, which is a big, long 4 to 8 hour test, or ADHD has attentional tests. And then in pain, the world of pain, you have the
Mm.
Michigan Pain Report. So it goes on and on. Every single, even within the pain area, like for migraines, they have multiple types of tests or
Mm.
neuropsych evals for different types of migraineurs. So there's all kinds of different neuropsych evals out there, but the common thread is that they're focused more on symptoms and
Mhm.
what are the symptoms that are causing them. And we prefer to think, we start at the base foundation and look at the underlying biology.
Mhm.
And so, like people in the pain world, we've worked with people in the pain world who uh, look at, okay, they look at people who have acute versus chronic pain, and they're trying to make a decision about surgery, about what
Mhm.
is the pain peripherally mediated or centrally mediated. And if it's centrally mediated, then you don't do surgery. If it's peripherally mediated, then you do. So, there's only a couple people doing that, but it's kind of fascinating to work with them and
Mhm.
see
How
how.
about other more sensitive brain measures like an MRI or PET scans?
Sure.
They're taking pictures and they're not necessarily looking at brain function like the brain
Right.
gauge does. Yeah.
Yeah, it's a really good point because the brain gauge is a measure of brain function. And we've done a lot of studies where we were compared to either functional MRI or MRI or MEG, EEG.
Hmm.
We did studies using TMS.
Mm.
And I'll give you an example in terms of resolution. The best resolution you can get with, say, an MRI or standard medical imaging is about 3 millimeters. So that's kind of far in the brain, because a micron is, well, is a lot smaller. A mini column, the functional unit of mini column, is about 35 microns. And so that's the functional base element that we studied at very high resolution in the brain. Now, the brain gauge, when it delivers stimuli to, say, 2 fingers, 2 digit tips, and we ask you the question, which one's larger? We deliver two
Hmm.
stimuli, and we deliver the intensity and change the intensity, change how hard it is on each finger, or the intensity. You can tell the difference down to about 10%. An fMRI, on the other hand, cannot do that. It
Hmm.
needs it needs to be about a 200% difference.
Oh, wow.
Okay, so
Wow.
before it can
Yeah.
see that
Yeah.
difference.
Yeah.
And the way to think about this is like, oh, so since its sensory test is actually much higher, has much better resolution than any medical imaging test.
Mhm.
So if you want to get an eyeglass prescription, you're going to read an eye chart. That's a sensory test. You're not going to go get in a scanner,
Yeah.
because if you were to get in a scanner, um, and they come back and nobody knew about an eye chart, they would probably give you eyeglasses that would look like Coke bottles, and they just wouldn't work.
Yeah.
They
Because they
won't.
can't get close enough. They can't get close enough to the pathway, the neural pathways,
Yeah,
basically,
exactly.
like the brain gauge can with the sensation of it.
Yeah.
Fascinating. Well,
One
that's
other example
yeah.
is magnetic resonance spectroscopy. That's a little bit
Mhm.
different. That it's used as an MRI to same thing, but it's looking at things like GABA levels. And
Mhm.
so some of our measures, all our measures are different and target different things, but some of those, we've done some studies where MRS has, which measures GABA levels, we showed correlations between that and some of our measures. Now, however, MRS cannot look at the difference between GABA A and GABA B, whereas we have a measure that does differentiate between those two. So we
Mhm.
can sort of split the difference and see, what is much more powerful than
Yeah.
that, the MRS, because it's a very finely tuned system for what you're looking at that difference.
Yeah.
The GABA A versus GABA B difference is a little longer story.
Yeah.
So I shouldn't even mention it.
I just think this is fascinating conversation. I think the equipment is so powerful. How long has it been available to the public?
Um, well, it's been available about 10 years,
10
but
years. Uh-huh.
the most recent model has been out since 2018.
Hmm. That's
So
7 years.
that's
Yeah.
that's pretty solid. That
Yeah.
that hardware is not going to change, and
Hmm.
that, the software we keep upgrading. But if you've got a brain gauge, the software upgrades come free. I mean,
Hmm.
it's a
Sure.
one. Once you purchase, it's you never pay for it again.
Yeah. Well, tell us about the product. So you have a couple of different versions,
We do. We
the
have a
home
we have
version and the pro version. Tell us about them.
Well, the pro version is what's used in clinics, and
Hmm.
it basically it's has unlimited testing, unlimited number of subjects, and it supports remote testing from home units.
Mm.
So the people in the clinics, they basically sometimes their patients will actually purchase brain gauge home units, and they can test at home. So
Mm.
generally, a lot of treatment plans involve people coming into the clinic, getting a treatment twice a week for a while, and then it goes to once a week, then it goes to once a month, etc. But meanwhile, you're not, they don't know when they need to come back for a tune-up.
Hmm.
But if
Yeah.
they've got a brain gauge at home and
Mm.
the clinic and they're testing at home, the clinician can actually
I
look
see.
at
Mm.
their data from their
Mm.
pro account, from the
Mm.
professional account,
Mm. Okay.
and they plug in and they're part of the clinic, whether they're at
Hmm.
home or in the clinic. It doesn't matter where they test.
Hmm.
And that's been pretty popular with people who have patients from very, very far away. And sometimes, patient care and just involves compliance with some kind of some new lifestyle change,
Yeah.
and
Yeah.
you can track
Yeah.
more often, and they can see whether they're
Mm.
complying with that.
Yeah.
They also use it for brain training. So people are doing brain training, and they do that 2 or 3 times a week or more.
Hmm.
And when they use the brain gauge for brain training, it does benefit to have their own. Uh, and
Yeah. Yeah.
you
We didn't really get into the training aspect or the treatment programs that can be kind of complementing what the dysfunction is or what the
right,
downside is, and you can apply some treatments. And that's probably another conversation. I mean,
it
so
probably is.
yeah, yeah,
It's very exciting, and it's
yeah.
really good to, it's great seeing people improve their scores. Like I
Yeah.
mentioned before, I've seen people improve their scores from just on reaction time. Again, the numbers mean nothing to most people except
Mhm.
me,
Mhm.
but reaction time improving from like 400 milliseconds down, which is like double what it should be, down to 200 milliseconds, and paralleling other things going on with that person, whether that's memory loss or Parkinson-like tremors that are very familial to the person,
Mhm.
and those things going back to normal, and the symptoms getting better from
Yeah.
brain training and changes
Yeah.
in lifestyle because they're
Yeah.
tracking themselves every day. It's pretty exciting.
Yeah. I know I had asked you earlier about using this in a clinical setting and whether it's billable to health insurance. Are there benefits? And you said
There
that
are
there are some cognitive CPT codes that cover
there are
cognitive training
yes. Yeah,
and therefore billable.
there are CPT codes for the testing.
Yeah.
Um, I don't I don't know if there's CPT codes for the training or not. That's just
Hmm.
something
Hmm.
gotten really, really busy in the last few months. And
Yeah.
the last time somebody asked that question, we said, we'll look into it. And we've been slammed. We
There's
haven't.
a few things to look into. Sure.
Yeah, we do have a few things to look into.
Yeah. Yeah.
It
That's great.
technically, yeah, technically it is sensory motor exercise equipment. So it can
Yeah.
be
Yeah.
treated as exercise equipment. So
Hmm.
if and
Hmm.
if you can bill for exercise equipment, then it can be billed for that way.
Hmm.
That's one way to bill
Hmm.
for it.
I know you generously offered a discount to listeners of this podcast and for the home version. Can you give us the retail cost of the home version?
Sure. The home version retails for 650,
650?
and
Okay.
we can offer a discount on that.
Yeah.
And we
Okay.
just if you go to our website,
Uh-huh.
the website's corticalmetrics.com, and then you just look at
Yeah.
products and go to the Brain Gauge Home.
Yeah.
And whenever you get to the checkout, just type in living to 100,
Uh-huh.
and that'll
A
put a
discount code?
code. That
Yeah.
discount code will take off 150, we'll say, I guess it was $150 off the home unit.
Wow.
It'll, or I think that's what you
Yeah.
mentioned at the beginning. So I figured, oh, I guess I'm
No.
well, let's say
Uh,
10%. 10% is easier for us to do the numbers on.
yeah,
So
10%. That's good. That's
take
that'd be
10% off the
six,
home unit. And if you're a
65 bucks.
professional, it'll
Yeah.
take 10% off the
Yeah.
professional.
Yeah.
So,
Okay, so that's the discount code at corticalmetrics.com.
and
Uh,
if you can't remember cortical metrics, type in brain gauge,
Brain
and
gauge.
that
Okay.
will be the website that pops
Okay.
up. And
Okay.
the most
Yeah.
common misspelling of brain gauge is Brian Gauge, but it won't find it for Brian Gauge.
I hope Brian doesn't mind that. Yeah. Yeah. So I'm seriously considering that myself. I think that's a really useful tool to have around. I like that. I like that. What do you see as the future in terms of brain health and measurements of brain health? What do you see in 5 years?
I think if people start measuring, and it's been very exciting because people are starting to realize, oh, for 90 seconds, I mean, the main cost for anything to anybody is time. And if they say 90 seconds, I can get a pretty good snapshot of where I am. And they start thinking about what can I do to keep my brain health going, and there's so many things to help with your brain health. And if you're just monitoring it and you know if it
Mhm.
works, you know if it helps, and or you
Mhm.
know if it doesn't work.
Mhm.
And and I see a lot and I see a lot of alternative strategies out there
Yeah.
that are seem to be very effective. And the way I know they're effective is because I'm looking at people's data. So I am the big brother of brain gauge. I can look at
Mm. Mm.
anybody that has a brain gauge,
Mm.
and I do look every day. I
Mm.
check into different, I just see, okay, who's testing today, and I see
Yeah.
how they're doing.
Yeah.
And sometimes I reach out and say, what the heck are you doing? Because you've improved
Mm.
so much.
Yeah.
And I've learned a lot that way.
Yeah.
I've learned a lot about different methods and for improving brain health. And I think there's a lot of treatments, or a lot of I don't know if you call it, they're not non-pharmaceutical treatments that are
Hmm.
very, very
Hmm.
effective
Yeah.
for keeping brains healthy
Yeah.
and young,
Yeah.
or healthy aging, I guess is the way to. we're not going to stay young, but we'll age in a healthy manner.
Yeah, and we can monitor that. That's the beauty of it. So you can get pre and post measures and see what we're doing right and see what we're not doing right. That's
Mhm.
great. Just one final question. Are there any concerns about misuse or kind of the um, uh, unforeseen effects of this, or no, I won't say in the hands, the wrong hands, just like any potential downside to it.
Well, we've been doing this for 10 years. I
Yeah.
haven't really seen any downsides
Hmm.
to tracking and monitoring.
Yeah.
I mean, the people that don't want to use it don't use it. Okay, and let me explain. One of the interesting conversations I had when we first released the product, and I got a lot of phone calls. I got a phone call from a gentleman, and he said he was all excited. He said, "Is the brain gauge going to show people that my supplements work?" And I said, "Well, only if your supplements are working."
Only if they're working. Sure.
And then he hung up the phone. He had no more interest in the brain gauge. And I was like, okay. So,
Mm.
I
No.
see people at meetings with magic wands, stuff like that. And I was
Yeah.
like, they don't really want to test.
Yeah.
So, the problem is there a downside to good science? And,
Hmm.
we've been working on this for 40 years, at least I
Hmm.
have.
Yeah.
And it's fascinating and science is fun,
Yeah.
and it's a very, even though there's a lot of science involved, it's kind of a common sense approach to
Yeah.
keeping your brain healthy because you just say, okay, let's see how I am and what do I need to do to get better. And I think as long as you're doing things to improve connectivity
Mm-hmm.
and not doing things to disconnect, and there's a
Hmm.
lot of things you can do to
Yeah.
disconnect.
Yeah.
They're usually
Yeah.
pharmaceutical related. So
Hmm.
I think you got a really good shot at
Yeah.
living very,
Improving.
having good healthy aging.
And there's a whole database of scientific research behind you that supports this and
Yeah, we've got about
supports your
well,
outcomes.
over I say over 120 publications, but
Yeah.
I'm no longer
Yeah.
there's a lot of people using the brain gauge and publishing that, and I'm
Yeah.
not really a part of it, and I have to
Sure.
go check and see how
Sure.
many there are.
Yeah. 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 Well, you've contributed quite a bit to this whole science and database. So thank you for that good work. It's a real
Yeah,
contribution. Yeah.
thank you.
Yeah. Well, Mark, it looks like we're out of time for today. But before I wrap up, I just want to remind my listeners to visit my website at living100.club. Sign up on the living100 community as a longevity insider, and you'll receive exclusive benefits, several of my publications, invitations to live discussions, and access to our private group forum. And if you're part of a senior living community, don't miss my Better, Longer, and Happier card deck series at living100.solutions with 12 engaging modules. It's a powerful tool for promoting wellness, personal growth, and meaningful conversation. Mark, thanks again for joining us today. And again, your website is corticalmetrics.com, and people can also search for brain gauge. So they can get more information about that and hopefully make a purchase themselves. Yeah.
And they can always reach out and contact me individually.
Okay.
My contact info is on the website.
Great. Great. And thanks to all of our listeners for tuning in. Hope to see you next time.